go in there, mittens, coveralls, face things, snorkel park, think, it's cold. So I said to the head guy, Todd Hinckley, Dr. Hinckley, why do you keep it, minus 36 Celsius? Is it to maintain the eutectic balance between certain isotopes of oxygen and certain... No, we didn't pick it. I took the thermostat and turned it all the way down. Dude, turned it all the way down. It's as cold as it will go, because they don't want this ice to evaporate. The ice is drilled out of the Antarctic ice cap. It's drilled out of Greenland, Vladivostok, the peninsula of Siberia. Take this ice to Glendale and look at it really closely. Take these big cylinders, 10 meters long, of ice, and you take them to the warm room. 27. Oh yeah, take out my hood. This is great. After a few minutes, you notice it's pretty fucking cold. All right, so you look at the ice carefully. I'm telling you people, it's much easier than counting tree rings. The ice layers are about that far apart, 10 centimeters, something like that, or 4 inches. Okay, and you can see when it was a lot of snow year, a little snow year, and a lot of snow year, and a medium snow year. You can just tell. As the snow falls down, the weight of the snow packs the layers below from season to season, and the tines of the snowflakes break and release a little heat and cause a little bit of melting or slushing, and that's called regolation. What a fabulous word. The snow is regulated. And then you get these clear pieces of ice. And in the clear pieces of ice are little bubbles. Tiny bubbles. Tiny bubbles. In the islands, I saw Don Ho. I must tell you. I saw Don Ho at a teacher convention in Hawaii, and he started singing Tiny Bubbles. For those of you who don't know about it, I'll get over it really fast. He started singing Tiny Bubbles. He said, sung that song every night for 30 years. And he said, I hate that song. He was good. He was quite charming. He was a good guy. But he's not alive now, so as far as I know, he's not singing it. But he's a good guy. Anyway, you live this whole life in Hawaii. Come on. I mean, it's not Texas. It's okay. It's okay. So if you look at the ice carefully, you see these little pieces of dust, grains of sand. These grains of sand in this particular picture got to Greenland from the Gobi, from the desert in China. And that just shows you the global scale of this business. Anyway, you look at the bubbles. They must needs be bubbles from the ancient atmosphere, going back 100 years, 200 years, 500 years, 1,000. The oldest one's 400,000 years. Okay, you look at the bubbles, there's no way for the bubbles to get in the ice unless they were trapped with the snowflakes. No other way to do it. So what you're looking at is the ancient atmosphere. And what these people do, they take a mass spectrometer, like they have in your car, measure the number of neutrons, especially in the oxygen molecules in the H2O of water. The warmer the sea surface, the more light oxygen evaporates, and you can tell when the sea surface is cool, fewer light oxygen evaporate, and you can figure out very accurately the temperature of the sea surface and infer the temperature of the world. Because people like the U.S. Navy keep extremely accurate records of sea surface temperature going back hundreds of years. Even the old thermometers were quite accurate, they still work, and they can work their way back and prove, show you absolutely that the world has never gotten this warm, this fast. And that is why I want you to change the world. Because you, most of you here, students, are members of what I call the climate generation. Now, to be a member of the climate generation is, I think, perhaps for most of you, even easier than being a member of the space generation. You have to be born after the 23rd of June, 1988. Yeah. And that's what going on. Yes, climate generation. Yes. Climate generation rocks. So, this is the day, the first day, that Dr. James has testified college student standards, 1988. By my standards, it was sort of last summer. Now, you've probably seen pictures like this. If you go to Patagonia, to Argentina, there's an ice sheet. Now, an ice sheet is a term that means a sheet of ice. A sheet of ice is a little different from a glacier because a sheet of ice is supposed to ride on ice, and the glacier is supposed to ride on the ground. But all that aside, there was a lot of ice there in 1928. If you go there now, from the same vantage point, take kind of the same picture, there is no ice. No ice sheet. It is muddy lake thing place. And this is a result of the world getting just a little bit warmer. Not summer, winter, just a little bit warmer. Over 50, 80, 70 years, the ice went away. There's many, many pictures akin to this. And the reason this is possible, the reason that the world can get warm this fast, is because the atmosphere is fantastically thin. The atmosphere, as my old professor Carl Sagan would say, is like a layer of varnish on a classroom globe. Here's a picture of the space. It's not the space station. It's a picture. I mean, the space station. By the way, so now if you look at the atmosphere on the edge, you'll see that you can't even notice it unless I point it out. You know, there's the atmosphere right there, and it is thin, 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 thin. And by the way, the International Space Station, if it were to fly above a classroom globe, barely gets a quarter of an inch above the globe.